I'm a doctor of chiropractic at the Rock Health and Wellness Center, and you are listening to Life with Jason Clemmons, DC. We're coming to you live from the Rock in our studios, and we're coming to you on the radio at 98.7 FM Walk by Faith and all of the associated stations that go along with it there. So, 987radio.com, the Live 365 app, and 1420 AM. So, this is Wednesday, September 27th, and this is going to be a fun show tonight. We're gonna break down a book called The Body by Bill Bryson. I think you're going to like it. It's a lot of fun. We're going to do it a little bit different than our last three breakdowns of books that we've done on Wednesday nights. I try to bring you a book that I've read somewhere along the way. And so our first one was The End of Alzheimer's that we broke down by Dr. Dale Bredesen. And then we broke down Bessel van der Kolk's The Body Keeps the Score. And then last Wednesday, we broke down Spark by Dr. John Rady. And so tonight is going to be kind of a chill, fun show. And we're just going to try to cover as much of the stuff as we can as we're going through it. And hopefully you enjoy it as much as I enjoy it. So, because we're going to try it a little bit differently than we've done those other books, because this book has so much information in it. It's written, the title is The Body, A Guide for Occupants. And it really is. It is, I don't even know how many total pages is. It's like 300 something pages. And he's got just references after references after references. It's 380 something pages. And I listened to it a couple of times. We had Dr. Joe Fraley, a couple of weeks ago on the show, right? And I got this book on tape, and I listened to it on tape. It makes me sound old, right? I don't know what I got it on. I got it on my app, Audible. Either got it on Audible or iBooks. I don't, whichever one that is. And so I got it, and it literally took, I think, the whole trip there and back. It was an 8-hour time listening to it, or even longer. There's a lot of information on it, and so we're going to get into it and just get started. And I'm just gonna read it. I mean, I'm not gonna read the whole 300 pages, but I'm just gonna start with each chapter. It breaks down the whole body, how to build a human. Then it goes skin and hair, then the microbes, the brain, the head, the mouth and throat, the heart and blood, chemistry department. It just goes through the whole thing. There's 23 chapters altogether in the book, and I think you're gonna like it. And it's going to be a different kind of show than what we've done before, because it's going to be a commentary as we go through it. I'm just going to kind of read some of it, and it's funny. Bill Bryson's a really interesting guy. If you don't know about him, he was born in Des Moines, Iowa, in 1951, and then he ended up settling in England in 1977. He worked in journalism until he became a full-time writer. He lived for many years with his English wife and 4 children in North Yorkshire. He and his family then moved to New Hampshire in America, and then they went back to the UK. So he doesn't, on the Audible part of this, he doesn't read the book, but he has an English person read the book, and there's just a lot of humor in it. There's a lot of humor. There's a lot of sarcasm. He's written a ton of books. In the front of this book, it breaks down 19 books that he's written. I think he's one of the leading authors in the history of Europe or something. But he's got 19 books that he's written. He's obviously a very successful human being, and he is a great writer. I really hope that you guys enjoy the book. And so that's what we're going to do tonight. We're going to get into it. But I first want to say one thing, because right before I got on the show tonight, I had one of my longer time patients that I've been taking care of told me that he and his wife listened to the show, and after a couple of the shows, she just decided, hey, I'm going to get the weight machine out. And Dr. Clemmons said that as we get older, we start losing bone density, and it's really important to keep our bones healthy so they won't get osteoporosis and have all kinds of problems with that, right? And one of the ways that you can increase your bone mass is to lift weights. And so she decided that she's going to get the weight machine out and start lifting. And they were talking about quit eating sugar. And I thought, man, that's fantastic. That's exactly what I wanted to hear. That's the reason that we're doing the show, right? It's because we're trying to share as much information with as many people as we can so that everybody can enjoy the health that they are supposed to have, right? Not this ill health that we all end up with because of the things that we do. So that was really cool. He was my last patient of the day that I adjusted, and right before, it's like 15 minutes before the show started tonight. He was my last guy, and so I was talking to him, and um, and that was really inspiring. So I hope people are getting something out of this. I hope you guys are enjoying it, and I hope you enjoy this one tonight. We're going to do it different, so we're just going to get after it. It's called The Body by Bill Bryson, and he starts off the book, and he's talking about when he was in junior high school in Iowa. He remembers being taught by a biology teacher all the chemicals that make up the human body could be bought in a hardware store for $5 or something like that, he says. And so he kind of goes through there, and he talks about perhaps the most respectable and comprehensive attempt of recent years was done by the Britain's Royal Society of Chemistry when, as a part of the 2013 Cambridge Science Festival, it calculated how much it would cost to assemble all the elements necessary to build the actor Benedict Cumberbatch, which I thought that was pretty funny. I was like, okay, we're going to build Benedict Cumberbatch. And how much is it going to cost us to do that? So they broke it down. They figured out exactly to the best of their ability, what it would cost to build him. Altogether, according to the RSC calculations, 59 elements are needed to construct a human being, 6 of those being carbon, oxygen, hydrogen, nitrogen, calcium, and phosphorus, accounting for 99.1% of what makes us. But much of the rest is a bit unexpected. We would have thought that we would be incomplete without some, I don't even know how to say this word, molybdenum inside us, or vanadium, manganese, tin, copper. Our requirements for some of these, it must be said, are surprisingly modest and are measured in parts per million or even parts per billion. We need, for instance, just 20 atoms of cobalt and 30 of chromium for every 9,999,999 and a half atoms of everything else. So these guys went through there, and they went through the whole thing. They were talking about all the things that cost you things, and they're like, 61% of the available space in the human body is oxygen. That's an interesting stat. It may seem a touch counterintuitive that we are almost 2/3 composed of this odorless gas. The reason we are not light and bouncy like balloons is that the oxygen is mostly bound up with hydrogen, which accounts for another 10% of you, to make water. So most of that oxygen is hooked with hydrogen to make water, and you know how heavy water can be. So oxygen and hydrogen are also 2 of the cheaper elements within you. Your oxygen will set you back just $14, and your hydrogen a little over $26. Compared to the calcium, phosphorus, and potassium, though needed in carbon. The carbon will cost you $69,550. The calcium, phosphorus, potassium will cost you $73,800. So when they got through putting all this together, Benedict Cumberbatch ended up costing $151,578.46 to build. I thought it was funny because the least of us, right? The least of us on earth today is worth at least $151,000. If you walk around today and you think, I'm not worth a flip, I'm not worth a dime, that's not true. You're worth at least $151,000, and that's not counting labor and tax. So after the labor and tax, they figured it'd be somewhere around $300,000 to build you. So you're worth something. The book says it right here, right? I thought it was pretty cool. Um, you get into all those different elements, illustrating a point that will become inescapable as the book goes on, namely that where the human body is concerned, the details are often surprisingly uncertain. It's hard to know exactly how much a person's worth or how much it would cost to make you. But anyway, um, that is unquestionably the most astounding thing about us, that we are just a collection of inert components, the stuff would make that you would find in a pile of dirt. I've said it before in another book, but I believe it's worth repeating. The only thing special about the elements is that it makes you, or that make you, is that they make you. That's the miracle of life, right? As we go through this, and as we go through this book, it's it's really obvious. You can put all the parts together, but there's nothing special about the parts. What's special is about you. And that's what we talked about on our show on the very first night when we talked about innate intelligence, right? We talked about innate intelligence and that spirit that runs your flesh, and that the flesh will go back to the dust. And we'll get into that in chapter 2 when we talk about skin. But the flesh of us is just pieces, but it's that innate intelligence, it's that spirit inside of us that actually makes us who we are, right? And that's why we spend so much time. That's what this show is all about, is just to try to help us understand that all these pieces, they fit together in a certain way, and they need a certain environment in order to express themselves. Really, that's what we're trying to do. We're trying to say, hey, look, sugar messes up the environment that all of these pieces fit together in. And so it's kind of cool as we go through here. We pass our existence within this warm wobble of flesh and yet take it almost entirely for granted. How many of us know even roughly where the spleen is or what it does? Or the difference between tendons and ligaments? Or what about lymph nodes? How many times do you suppose you blink? 500? 1,000? You have no idea, of course. Well, you blink 14,000 times a day, so much that your eyes are shut for 23 minutes of every waking day. That's interesting. Yet you never have time to think about it because every second of your day, your body undertakes a literal, unquantifiable number of tasks, a quadrillion, a nonillion, a quintillion. I don't even know. Those words are big, right? All of the events, some number vastly beyond imagining, without requiring an instant of your attention, right? We talked about how special your brain is, how amazing your brain is, right? You can handle all of those things. You can blink 14,000 times in a day if your eyes are closed for 23 minutes in a day, and you don't even think about it, right? You have a specialness inside of yourself that's just amazing, right? Altogether, it takes 7 billion atoms to make you. No one can say why those 7 billion have such an urgent desire to be you. That's interesting. They are mindless particles, after all, without a single thought or notion between them. Yet somehow, for the length of your existence, they will build and maintain all the countless systems and structures necessary to keep you humming, to make you you, to give you the form and shape, and let you enjoy the rare and supremely agreeable condition known as life. 7 billion atoms make up you and give you life, right? That's a much bigger job than you realize. Unpacked, you are positively enormous. Your lungs, smoothed out, would cover the tennis court. The air within them the airways within them would stretch nearly from coast to coast. The length of all your blood vessels would take you 2.5 times around Earth. The most remarkable part of all of is your DNA. You have a meter of it packed into every cell, and so many cells that if you formed all the DNA in your body into a single strand, it would stretch 10 billion miles beyond Pluto. Think of it. There's enough of you to leave the solar system. You are the most literal sense cosmic. Right? That's an interesting thought. You have a meter of DNA in your cells, and you have the 37 something million cells or billion cells in your body, trillion cells in your body. That's really interesting right there. So it's just, you study the human body, and you I had a patient this afternoon. She was talking about, do you get excited when you're about to adjust someone? Like, is it exciting for you to to when you she's like, first of all, I said, how was your day? She said it was good, just doing the same old thing. And I said, how was your day? And I said, well, I just been working on spines. And and she was like, is that exciting? And I was like, yeah. And she said, how was most of them? And I said, well, most of them are pretty healthy, but I've got some of them that are jacked up. And that's when she asked me, do you get excited when you're working on those jacked up spines? And I just kind of laughed. I was like, well, I get excited when I'm working on every spine because of things like this in this book, that 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 the person I'm working on has enough DNA inside them to stretch from here past Pluto, right? It's like, that's you're an amazing creature. And when you read books like this, it's just super crazy how, when you every sentence that he has in here is giving us information about how our body works. The heart of the cell is the nucleus. It contains the cell's DNA, 3 feet of it. As we have already noted, scrunched into a space that may reasonably call infinitesimal. The reason so much DNA can fit into the cell nucleus is that it is exquisitely thin. You would need 20 billion strands of DNA laid side by side to make the width of the finest human hair. I'm going to read that again. You would need 20 billion strands of DNA laid side by side to make the width of the finest human hair. Every cell in your body, strictly speaking, every cell with a nucleus, holds 2 copies of your DNA. That's why you have enough to stretch to Pluto and beyond. DNA exists for just one purpose: to create more DNA. That's kind of interesting. Your DNA is simply an instructional manual for making you. A length of DNA is divided into segments called chromosomes and shorter individual units called genes. The sum of all your genes is called your genome. So those are just some like sentences or words that you might have heard somewhere along the way. What is a chromosome? What is a gene? What is a genome, right? It's all those genes put together. The DNA is extremely stable. It can last for tens of thousands of years. It is nowadays what enables scientists to work out the anthropology of every distant past. Probably nothing you own right now, no letter or piece of jewelry or treasured heirloom, will exist 1,000 years from now, but your DNA will almost certainly still be around and recoverable if only someone would bother to look for it. That's interesting. Your DNA is going to be here for thousands and thousands of years, right? This book won't. This book will go back to the dust, but your DNA will still be around. DNA passes on information with extraordinary fidelity. It makes only about one error for every billion letters copied. Still, because your cells divide so much, that is about 3 errors or mutations per cell division. Most of those mutations the body can ignore, but just occasionally they have lasting significance. And how we can get those, sometimes those diseases that happen to us, right? Because or some of our genetic things that go wrong. All the components of the genome have one single-minded purpose: to keep the line of your existence going. It is slightly humbling through the thought that the genes you carry are immensely ancient and possible, so far anyway, eternal. You will die and fade away, but your genes will go on and on so long as you and your descendants continue to produce offspring. And it is surely astounding to reflect that not once in the 3 billion years since life began, or however you see that, your personal line of descent been broken. Not once has it been broken. For you to be here now, every one of your ancestors had to successfully pass on its genetic material to a new generation before being snuffed out or otherwise sidetracked from the procreative process. That's quite a train of success. If you think about that for a second, the DNA that's inside of you, where did it come from? It just kept getting passed down and kept getting passed down and kept getting passed down, right? The paradox of genetics is that we are all very different and yet genetically practically identical. All humans share 99.9% of their DNA, yet no two humans are alike. The 0.1% is what makes us different. That's an interesting thought. The 0.1% is what makes us different. My DNA and your DNA will differ in 3 or 4 places, which is the smallest proportion of the total, but enough to make a lot of difference between us. You also have within you about 100 personal mutations, stretches of genetic instruction that don't quite match any of the genes given to you by either your parents, but are yours alone. How all this works in detail is still largely a mystery to us. Only 2% of the human genome codes for proteins, which is to say only 2% does anything demonstrably or unequivocally practical. Quite what the rest is doing is unknown. Think about that. 98% of your DNA, what it's actually doing is unknown. A lot of it, it seems, is just there, like freckles on skin. Some of it makes no sense. One particular short sequence called an ALU element, I don't know if that's repeated, if that's proper, is repeated more than 1 million times throughout your genome, including sometimes in the middle of important protein coding genes. It is completely gibberish as far as anyone can tell, yet it constitutes 10% of all our genetic material. Now we know it's not gibberish. We just haven't figured it out yet, right? That's what it means when scientists and doctors and all that stuff say call it idiopathic or gibberish or something like that. That just means they haven't figured it out yet. That doesn't mean it doesn't have a function. No one has any idea why. The mysterious part was for a while called junk DNA, but now it's more graciously called dark DNA, meaning that we don't know what it does or why it's there. Some is involved in regulating the genes, but much of it remains to be determined. Super cool, right? Even when you do nearly everything wrong, your body maintains and preserves you. So it's talking, let me back up. And how do we celebrate the glory of our existence? Well, for most of us, it's by eating maximally and exercising minimally. Think of all the junk you throw down your throat and how much of your life is spent sprawled in a near vegetative state in front of a glowing screen. Yet, in some kind of miraculous way, our bodies look after us, extract nutrients from the miscellaneous foodstuffs we put into our faces, and somehow hold us together, generally at a pretty high level, for decades. Suicide by lifestyle takes ages, right? You think about how glorious we are and how amazing we are, and then you think about the crap that we put inside of our bodies and the things that we do to ourselves. It's crazy. Even when you do nearly everything wrong, your body maintains and preserves you. Most of us are a testament to that in one way or another. 5 out of every 6 smokers won't get lung cancer. Most of the people who are prime candidates for heart attacks don't get heart attacks. Listen to this part. Every day, it has been estimated between 1 and 5 of your cells turns cancerous, and your immune system captures and kills them. Think of that. A couple of dozen times a week, well over 1,000 times a year, you get the most dreaded disease of our age, and each time your body saves you. I've known that for a long time. Every single day, that's one of the things that my brother-in-law used to say when I went to work for him. Every single day, your body creates cancer cells. And every single day, your immune system recognizes that those are cancer cells and gets rid of them. So when you run your immune system down, when your immune system fails you, then the cancer grows and that's what kills you, right? So it's the immune system it's saving your life is your immune system. Well, what are the things that we do to drive our immune system down? We get stressed out and we stay stressed out. We don't stay active and move, both exercise and spinal, if you listened to the show last night. We eat too much sugar and refined carbohydrates that drives our immune system down. And we don't think about it. We're going to talk about bacteria here in the next few chapters, but we don't think about we don't think about our immune system saving us from cancer. We don't recognize that a weak immune system might let some of those cancer cells get away or escape, right? So the better immune system we can have, the better and health we can have, and less cancer we're going to have. So um, we're coming up on a break on the radio station. We've got a minute before we break into the break, but I just want to finish some of these right here. Our bodies are a universe of 37.2 trillion cells operating in more or less perfect concert, more or less all of the time. We get the aches and the twinges and the indigestion and odd bruises or whatever, but for the most of the time, we handle it pretty good. There are thousands of things that can kill us, slightly more than 8,000, according to the International Statistics Classification of Disease and Related Health Problems, compiled by the World Health Organization, and we escape every one of them except for one. There's 8,000 things that can kill us, but only one thing is going to kill us. So we're going to miss all the rest of them. It's pretty amazing. We'll be back right after the break on the radio, and we'll stay live on Facebook. We are not perfect by any means, goodness knows. We get impacted molars because we have evolved jaws too small to accommodate all the teeth that we are endowed with. We have pelvises too small to pass children without excruciating pain. We are hopelessly susceptible to backaches. We have organs that mostly cannot repair themselves. If a zebrafish damages its heart, it grows new tissue. If you damage your heart, well, too bad. Nearly all animals produce their own vitamin C, but we can't. Did you hear that? We can't. We can't make our own vitamin C, so we have to eat it. We undertake every part of the process except, inexplicably, the last step, the production of a single enzyme. The miracle of human life is not that we are endowed with some frailties, but that we aren't swamped with them. Don't forget that your genes come from ancestors who most of the time weren't even human. Yeah, we get a little sideways on some of the stuff right here, right? But that's Bill Bryson's opinion. We'll just go with that. When we come back after the break, I'm going to start. The next one is the skin and hair. And some of this will gross you out, but we're going to go through it anyway. When I was trying to decide how we were going to break this down, it was tough. I was like, I know the people aren't going to want me to just read this book to them. But when I started trying to break this down, every single sentence had something. I mean, there was so much information in the book, and I just hated to miss it because like, who knows which one of these sentences are the ones that's going to make a difference to someone that's listening. I wouldn't have known that the I wouldn't have known that the sentence about osteoporosis was going to make the lady want to start lifting weights, right? So we started taking this book, and he's got so much information in the book that it's just really amazing. So we'll get into it. We're going to go through this next segment. Is called the outside, the skin and hair. And his quote to start this right here says, "Beauty is only skin deep, but ugly goes clean to the bone." Right, Dorothy Parker. He's got a great sense of humor. This is a lot of fun. I'm having fun. I don't know if you guys are having fun or not. Sometimes we could just loosen up just a little bit instead of getting so serious about all this big stuff that we talk about on the show. And that's what's cool about this book. It's so much information. All right, coming back. Just give me 1 second. We'll come back from the radio. Okay, we're back from the break. This is Life with Jason Clemmons, DC. It is Wednesday, September 27th, and we're coming to you from the Rock Health and Wellness Center, and we're also on 98.7 Walk by Faith radio. So I hope you guys are enjoying the show. We're breaking down the book, The Body by Bill Bryson. It's a fantastic book. There's a lot of information in it. And we're doing it a little bit different tonight because we're just trying to go through and cover. This book is so packed with so much information that I didn't know how to just skip through it. So we're just kind of hitting some of the highlights of each chapter, and it may take us several weeks to break down this book. So we'll just randomly come back to it when we need a little break and not be so serious about all the things that we talk about on a regular basis. We'll just come back to the show and break down the book. So we're in chapter 2, the outside, skin and hair. It may be slightly surprising to think, but our skin is the largest organ and possibly the most versatile. Did you know that your skin is an organ? It keeps our insides in and bad things out. It cushions blows. It gives our sense of touch, bringing us pleasure and warmth and pain and nearly everything else that makes us vital. It produces melanin to shield us from sun's rays. That's what a tan is. Is the melanin actually covers the nucleus of the DNA, of the cell, to protect the DNA. So when you get exposed to sunlight, your body creates melanin to protect the DNA so it doesn't get too much of that radiation from the sun, so that you don't have, when that DNA is trying to copy itself, you don't have breakdowns from the copying. Oh, sorry. I apologize to the radio people. I didn't turn the mic on. So we are breaking down chapter 2 of the the Body by Bill Bryson. Apologize for that. So we're talking about the skin. A formal name for the skin is the cutaneous system. The size is about 2 square meters, and it all told, your skin will weigh somewhere in the region of 10 to 15 pounds. I know people get really fussy about that because when they're trying to lose weight, they have a problem with their skin, right? Um, it's the thinnest on the eyelids. It's the thickest on the heels of your feet and hands. Unlike the heart or kidney, the skin never fails. Our seams don't burst, and we don't spontaneously sprout leaks, says Nina Jablonski, professor of anthropology at Penn State University, who's broken this, and she knows everything there is to know about the skin. The skin consists of an inner layer called the dermis and an outer layer called the epidermis. The outermost surface of the epidermis, called the stratum corneum, is made up of entirely dead cells, and it is an arresting thought that all of these that makes you lovely is deceased. So let me say it again. It is an arresting thought that all that makes you lovely is deceased, meaning what we see when we look at someone are dead cells. And when we look at, that's what's on the outside of us. The body meets air. Where the body meets air, we are all cadavers. These outer skin cells are replaced every month. We shed skins copiously, almost carelessly, some 25,000 flakes a minute, over 1 million pieces an hour. That's one of the things I always say to patients when we're talking about, hey, you can be healthier tomorrow than you are today. You can be healthier in a week than you are today. And the reason for that is because your body is constantly turning itself over. These are not 52-year-old whiskers that are on my face. Matter of fact, they were clipped off and they grow back and they were clipped off. You don't have, however old you are. These are not 51-year-old fingernails, right? Your skin, this is not, 52-year-old fingernails. This is not 52-year-old skin. We shed skin all the time, almost carelessly, some 25,000 flakes a minute, over 1 million pieces an hour. Run a finger along a dusty shelf, and you're in large part clearing a path through fragments of your former skin. Silently and remorsefully, we turn to dust, right? We turn to dust. But underneath that, when we're alive, we regrow new skin cells. So if you put yourself in an environment that's congruent with health, you will grow better skin cells as you replace them. If you put yourself in an environment that is incongruent with health, you will grow less healthy skin cells, right? And the same thing happens with bone. And the same thing happens with red blood cells. And the same thing happens with all the tissues in your body. The lining of your intestine lasts 3 days. We'll probably get to that in the book, right? So if you have a leaky gut problem and that's causing you joint pain and inflammation and all kinds of other allergies and immune responses and all that sort of thing, autoimmune diseases, all comes back to that gut, right? Those cells are dying and replacing themselves every 3 days. So you can completely, in 21 days, you can have 7 revolutions of new cells. That's why when we do our detox here in the office with Standard Process, we do a 21-day detox, which tells me if that person will stop attacking their gut lining with processed food and all the crap that we eat, and they will eat healthy for 21 days, they will get 7 revolutions of new cells in their gut lining. And what will happen is it'll close up all those gaps and they will end up having a healthier gut. They can stop that leaky gut problem, and then they can stop a lot of that joint problem that they've got, or immune response, or whatever that goes along with leaky gut. So the same thing happens with our skin right there, right? Skin flakes are properly called squamate scales. We each trail behind us a pound of dust every year. If you burn the contents of a vacuum cleaner bag, the predominant odor is the unmistakable scorched smell we associate with burning hair. That's because skin and hair are made up of largely the same stuff, keratin. I know it's not a great thing, and you may be eating supper right now. And if you're eating supper and you're listening to that, I apologize for that. Right? Beneath the epidermis is the more fertile dermis, where resides all the skin's active systems: blood, lymph vessels, nerve fibers, the roots of hair follicles, glandular reservoirs, and of sweat. Yes, all that happens below the skin. Beneath that, and not technically part of the skin, is a subcutaneous layer where fat is stored. So it just kind of keeps moving down through there, right? Nobody knows for sure how many holes you have in your skin, but you're pretty seriously perforated. Most estimates suggest you have somewhere in the region of 2 to 5 million hair follicles and perhaps twice that number of sweat glands. That's really interesting. 2 to 5 million hair follicles on your skin. The follicles do double duty. They sprout hairs and secrete sebum from sebaceous glands, which mixes with sweat to form an oily layer on the surface. This helps keep the skin supple and to make it inhospitable for many of the organisms. So your skin's really amazing right there. Also packed into the dermis are a variety of receptors that literally in touch with the world. If a breeze plays lightly on your cheek, it is your Meissner's corpuscles that let you know. When you put your hand on a hot plate, your Ruffini corpuscles cry out. Merkel cells respond to constant pressure, Pacinian corpuscles to vibration. Those are what I talked about when we talked about like the homunculus in the hand, and we talked about 2,500 per square centimeter receptors in your fingertips, right? What he's saying right there in the book, the Meissner's corpuscles, the Ruffini corpuscles, the Merkel cells, and the Pacinian corpuscles, those are the nerve receptors in the skin that are connected to your brain. And that's how you know the difference between things. That's what he's trying to say. If you know the difference, if you put your skin on a hot plate, right? Or you respond to constant pressure, or if it's vibration, you can know those things. Meissner's corpuscles are everyone's favorites. They detect light, touch, and are particularly abundant in our erogenous zones and other areas of heightened sensitivity. Excuse me, there. Fingertips, lips, and tongues, etc. They are named after the German anatomist George Meissner, who is credited with discovering them in 1852, though his colleague Rudolf Wagner claimed, in fact, that he was the discoverer. The two men fell out over the matter, proving that there is no detail in science too small for animosity. It's kind of funny. He'll go through the whole book and talk about that same type of thing right there. He'll talk about how one guy created it or figured it out and somebody else got credit for it, or how that all worked. But I thought it was cool just to know that. You got Meissner's corpuscles, in your fingertips, right? In your tongue and in your lips, right? And why are they called that? Well, in this particular case, George Miser's the one in 1852 that figured that out. All are exquisitely fine-tuned to let you feel the world. A Pacinian corpuscle can detect a movement as slight as 0.00001 millimeter, which is practically no movement at all. More than this, they don't even require contact with the material they are interpreting. David Linden points out in his book Touch, if you sink a spade into gravel or sand, you can feel the difference between them even though you are touching the spade. That's kind of interesting right there, right? If you put a shovel in the ground, then you can feel the difference, but you're not touching the difference. You're feeling it in your hand. And that's what's so amazing to me about the nervous system is the nervous system is so amazing that it has the ability to detect the difference between those things. This next one is really interesting. Curiously, we don't have receptors for wetness. We only have thermal receptors to guide us, which is why when you sit down on a wet spot, you can't generally tell whether it's really is wet or just cold. That's kind of what you're not necessarily knowing that it's wet. You just feel it, and then your brain interprets the information. Women are much better than men at tactile sensitivity within fingers, but possibly just because they have smaller hands and thus a more dense network of sensors. An interesting thing about touch is that the brain doesn't just tell you how something feels, but how it ought to feel. That's kind of interesting. That's why the caress of a lover feels wonderful, but the same touch by a stranger would feel creepy or horrible. It's also why it's so hard to tickle yourself. So your sensory information, your sensory information has to be integrated into your brain, and your brain's going to tell you, it's going to pre-tell you what it thinks it's supposed to feel like. It's kind of an interesting thought, I think. It's like your how you define, that's what I got into the other night, right? How you define your world is going to present your world to you. So how is something supposed to feel? Man, that's supposed to feel good. Oh, that hurts. That's supposed to feel bad. It's exactly the same touch, but we defined it differently, and therefore we created a response differently to it because of the way that we defined it. And then I think that's an interesting thought right there. It's just kind of like how many things do we do with that? We do that with our food. We do that with ways that the way the day is supposed to go. Remember the other day when I talked about getting fussy about the football game because I went to the football game forgetting that I was dad, and I went to the football game and acting like I was an ex coach and an ex player. Um, I got all fussy, and the football game was just the same. It's like the football game didn't change, but my definition of the event changed, and therefore my reaction of the event changed. I think that's an interesting thought right there, right? One of the most memorable, unexpected events I experienced. This is Bill Bryson talking. One of the most memorable, unexpected events I experienced in the course of doing this book came in a dissecting room at the University of Nottingham in England when a professor and surgeon named Ben Oliver, about whom much more in due course, gently incised and peeled back a sliver of skin about a millimeter thick from the arm of a cadaver. It was so thin to be translucent. That, he said, is where all your skin color is. That's all that race is, a sliver of epidermis. That's kind of interesting too, right? Once you get past that very layer of skin on the outside, we all look the same on underneath. It's like what we're judging every day when we judge people by their skin color, whether it's white or black or brown or whatever, right? What we're judging is a very thin layer of skin right there. Once we cut it back, we're all the same. I mentioned this to Nina, his friend Nina. He's talking again. When we met in her office in State College, Pennsylvania, soon afterwards, she gave a nod, a vigorous assent. It is extraordinarily how much or how such a small facet of our composition is given so much importance, she said. People act as if skin color is a determinant of character when all it is a reaction to sunlight. Biologically, there is actually no such thing as race. Nothing in terms of skin color, facial features, hair type, bone structure, or anything else that is definitely quality among peoples, defining quality, or anything else that is a defining quality among peoples. And yet, look how many people have been enslaved or hated or lynched or deprived of fundamentals rights through the history because of the color of their skin. I'm not getting into a political statement about this, right? I'm just simply saying that there, when you get past that one layer of skin, the human being is the human being. And so what we're judging is just that one layer of skin, right? And I also want to say that because I also have had some patients over the years that have said things to me like, well, it's my culture. We all have diabetes. It's like, well, we're prone to have diabetes. And it's like, no, that's ridiculous. That you may have diabetes because you eat too many tortillas. You may have diabetes because you eat too many donuts. You may have diabetes because you eat too much refined sugar. But you're not susceptible to diabetes as a culture. You may be as a culture for cultural reasons, but not biologically. It's not a thing. You're using that cultural excuse to take yourself off the hook when it comes to that. But it's not. It's just like being from East Texas or whatever. You say, "Well, hey, I'm a meat and potatoes guy." Well, that's ridiculous. I mean, it's 2023, right? The meat and potatoes argument should have died by now. Like that whole concept, that we ought not to, that hey, I got to have a biscuit. I got to have a. That's ridiculous. And I hope that our people are thinking that as they're going through this. I hope that they're picking that up and understanding that, right? Because biologically, that doesn't make any sense. Um, a tall, elegant woman with silvery hair cut short. This lady Nina works in a very tidy office on the fourth floor of the anthropology building in Penn State campus. But her interest in skin came about almost 30 years ago when she was a young primatologist and paleobiologist at the University of Western Australia in Perth. While preparing a lecture on the difference between primate skin color and human skin color, she realized there was surprisingly little information on the subject and embarked on what became a lifelong study. What began as a small, fairly innocent project ended up taking over a big part of her professional life. And she wrote a book about it. Skin color turned out to be more scientifically complicated than anyone imagined. Over 120 genes are involved in pigmentation in mammals, so it's really hard to unpack it all. What we can say is this: skin gets its color from a variety of pigments, of which the most important is by far a molecule formerly called eumelanin, but known universally as melanin. It is one of the oldest molecules in biology and is found throughout the living world. It doesn't just color skin, it gives birds the color of their feathers, fish the texture and luminance of their scales, squid the purple blackness of their ink, and even more involving in making fruits go brown. In us, it also colors our hair. Its production slows dramatically as we age, which is why older people's hair tend to turn gray. So what was actually happening right there, according to Nina, is that you're getting gray hair. We're all getting gray hair because we're losing that melanin. Melanin is a superb natural sunscreen. It is produced in cells called melanocytes. All of us, whatever our race, have the same number of melanocytes. The difference is in the amount of melanin produced. Melanin is often responds to sunlight in a literal patchy way, resulting in freckles, which are technically known. Yeah, I'm not going to go into that. Skin color is classically example of what is known as convergence evolution. That is, similar outcomes that have evolved in two or more locations. The people say of Sri Lanka and Polynesia have light brown skin, not because of any direct genetic link, but because they independently evolved brown skin to deal with the conditions where they live. So that's what a tan is, right? A tan is our skin color changing and to protect ourselves from sunlight. We actually did that in the lab in chiropractic school. When I was in chiropractic school, we did a with UV light and looked at cells, and we could actually see what was happening and why we get a tan. And that's kind of an interesting thing right there. It has been suggested that light skin may be a consequence of human migration and the rise of agriculture. The augmented the argument is that hunter gatherers got a lot of their vitamin D from fish and game, and that these inputs fell sharply when people started growing crops, especially as they moved into northern latitudes. It therefore became a great advantage to have lighter skin to synthesize extra vitamin D. Vitamin D is vital to health. It helps to build strong bones and teeth and boost the immune system, right? We've talked about vitamin D. It fights cancers and nourishes the heart. It is thoroughly good stuff. We can get it in two ways, from the foods we eat or through sunlight. The problem is that too much UV exposure damages DNA in our cells and can cause skin cancer. I'm going to present for consideration that the majority of that skin cancer is a result of an unhealthy skin. I think what happens to us, based on the information that I've got, and I'm not a dermatologist or a medical doctor, but based on the information that I've got, what happens to us is that we don't have the proper nutrients in the skin. And therefore, when the skin gets exposed to the UV light, it causes damage, and that can cause the cancer. So getting the right amount of vitamin D is tricky balance, or the problem is that too much UV exposure can cause it. So getting the right amount is tricky balance. Humans have addressed the challenge by evolving a range of skin tones to suit sunshine intensity in different latitudes, right? And that's what it's going to go on to say is that the darker the skin, the more difficult to create the vitamin D in the skin, right? So that's something that is a very interesting thing right there. At all events, a slow evolution of different skin tones worked fine when people stayed in one place or migrated slowly. But nowadays, increased mobility means a lot of people end up in places where sun levels and skin tones don't get along at all. That's an interesting thought. In regions like Northern Europe and Canada, it isn't possible in the winter months to extract enough vitamin D from weakened sunlight to maintain health, no matter how pale one's skin is. So vitamin D must be consumed as food, and hardly anyone gets enough. And not surprisingly, to meet dietary requirements from food alone, you would have to eat 15 eggs or 6 pounds of Swiss cheese every day or more, plausibly, if not more palatably, swallow half a tablespoon of cod liver oil. In America, milk is helpful supplemented with vitamin D, but it still provides only a third of the daily adult requirements. In consequence, some 50% of people globally are estimated to be vitamin D deficient of at least part of the year. In northern climates, it's as much as 90%. And that's really important as we get into, we're almost done with September here this week. So we're going to get into October, and we're starting to get into that time of year when our vitamin D levels are going to drop. And so for a couple of reasons, the sun moves away from the earth, the UV light that we get changes, so our ability to make vitamin D changes. And then the other thing is it gets cold, so we cover up, right? So we're not getting the same amount of sunshine that we got. So we're about to that time of year where it's a big deal to take your vitamin D or take your cod liver oil, whichever one you want to take, right? But, we call it flu season in the winter, but people get the flu in the summer, right? So you could get the flu in the summer, but we don't call it flu season in the summer. We call it flu season in the winter. And I got it presented to me at one time in my life that maybe it's not actually flu season. Maybe it's low vitamin D season. Maybe that's what happens to us. We lose our vitamin D, and then all of a sudden we start having trouble, right? And our immune system doesn't work properly, and then everything goes haywire from there. So I apologize to the radio people at the beginning of the segment. I didn't hit the microphone, so you have to forgive me for that. And Bob and Ken listening to the show, I apologize for that. Otherwise, thank you guys. That's we're getting to the end of the show now, and I want to say thanks for listening to it. I hope it was fun. I hope you learned some stuff. I know there's like a ton of information right here, and periodically we'll come back to this book and we'll see if we can keep it going. You're really going to be interested when we get into the microbes and get into the bacteria and the viruses, and then when we get to the brain, it's super cool too. So we might pick that up here in the next couple of Wednesdays or see how we want to break down this book. So thank you guys for listening. I hope you have a great night, and we'll see you guys next week, or actually tomorrow night.